Chapter 1.6.11 Storage Capacity. In Kubernetes v1.24, storage capacity is limited and varies depending on the node where a pod runs. Network-attached storage may not be accessible by all nodes, and storage can be local to a node. The scheduler uses information on storage capacity to schedule pods onto nodes with enough capacity for the remaining missing volumes. Without storage capacity tracking, the scheduler may select a node without sufficient capacity, leading to multiple scheduling retries. This feature ensures efficient use of storage resources by matching pods with nodes that can provide the necessary storage capacity. Before you begin, Kubernetes v1.31 now has cluster-level API support for storage capacity tracking, but users must have a CSI driver that supports this feature. Users should refer to the documentation for their CSI drivers to see if capacity tracking is available and how to use it. If not running v1.31, users should check the documentation for their specific version of Kubernetes for more information. The CSIS storage capacity objects are API extensions that are produced by a CSI driver in the namespace where the driver is installed. These objects contain capacity information for a storage class and specify which nodes have access to that storage. The CSI driver spec.storage capacity field, when set to true, allows the Kubernetes scheduler to consider storage capacity for volumes using the CSI driver. This feature helps optimize storage allocation and distribution within the Kubernetes cluster. Storage capacity information is utilized by the Kubernetes scheduler in certain scenarios. This includes when a pod requires a volume that has not been established yet. The volume is linked to a CSI driver with wait for first consumer volume binding mode, and the relevant CSI driver object has storage capacity set to true. In such cases, the scheduler only looks at nodes with sufficient storage capacity for the pod. The comparison is straightforward, considering the volume size against the capacity specified in CSI storage capacity objects associated with the node's topology. For volumes with immediate binding mode, the storage driver determines where the volume is created, regardless of pod location. The scheduler then allocates pods to nodes with the available volume. However, for CSI ephemeral volumes, scheduling is conducted without taking storage capacity into account. This is because this volume type is typically used by specific CSI drivers localized to a node and does not require substantial resources. Rescheduling. In Kubernetes, when a node is selected for a pod with wait for first consumer volumes, the decision is not final. The CSI storage driver is then requested to create the volume with the understanding that it should be available on the selected node. However, if the volume cannot be created due to outdated capacity information, the node selection is reset and the Kubernetes scheduler will attempt to find a different node for the pod. This process ensures that the volume is created successfully on a suitable node. Limitations. Tracking storage capacity can improve the chances of successful scheduling, but it cannot guarantee success due to potentially outdated information. Schedulers may still face failures, particularly when pods use multiple volumes and one segment has insufficient capacity for another volume. In such cases, manual intervention is required to rectify the situation, such as increasing capacity or deleting existing volumes. The retry mechanism for scheduling without storage capacity information is typically used to address such failures. Ultimately, While storage capacity tracking can enhance scheduling efficiency, it is not foolproof and may require human intervention in certain scenarios.